Okay, hi guys. This is the last time we are going to do a little bit more notes on the distributive property where we're just practicing a few different versions of what this could look like. So if we look at example 1 right here, we have a number, this time it's a fraction in front of parentheses, and that fraction is being multiplied by these parentheses. So this is going to be an example of a distributive property. We're going to end up doing that 1/4 times 12x and the 1/4 times, we've got to be careful, it's not really an 8. What would we have to change the subtraction to? Plus a negative, add the opposite. So that's really a -8. But this is still a regular old distributive property problem, just as if it wasn't a fraction. So when we go through and do this, think about what we know of fractions. 1/4 times 12x. Another way to say times is of. So what's 1/4 of 12? A fourth of 12 is the same as thinking as 12 divided by 4. So a fourth of 12, 12 divided by 4 is 3, and there's still a times x there. And then over here we do 1/4 times -8. So a positive times a negative we know is going to be a negative. And what's 1/4 times 8, or 1/4 of 8? A fourth of 8 is like 8 divided by 4, which would be 2. And we bring down our plus sign in the middle. And there is our simplified version of that expression using the distributive property. So let's try another one where the numbers might not be quite as nice to give us all whole numbers in here, because we don't have to have whole numbers. So example 2, the first thing I'm going to do is change the subtraction to adding the opposite. Okay. And we've got a 1/6 on the outside this time. So that just means it's going to be 1/6 times this 3y and 1/6 times the -7. So let's try 1/6 times 3y. 1/6 of 3y. Can I do 3 divided by 6? I mean, I could. 3 divided by 6 is just 3 divided by 6, 3/6. So 1/6 of 3 is 3 divided by 6. And I keep my y there. Now I'm going to be able to make that into a simpler fraction in a minute. Plus 1/6 of -7. A positive times a negative is going to be a negative, and 1/6 times -7, or 1/6 of 7 right here, is going to be 7 divided by 6. 7 divided by 6, 7/6. So it doesn't give us whole numbers, but we can still deal with these as fractions. Can I just simplify any of these fractions? 3/6 is the same as 1/2. I could just divide them both by 3, the numerator and denominator by 3. We get 1/2 y plus, how could I simplify -7/6? Well, it would still be negative. 6 goes into 7 how many times? Once, with 1/6 left. So this would be our simplified expression this time using the distributive property. So if you have a fraction in there, don't let it throw you off. It's the same rules. We just have to figure out how to deal with it as a fraction. So these examples down here, look at 3 and 4. They don't look the same as ones we've been doing. All right, what's different about these? They've got division on there. This is divided by 3, this is divided by 2. So this does not look like a distributive property example that we are used to, because we're used to having a number in front. But really, this is also the distributive property. I want you guys to think about dividing by 3. Dividing by 3 is the same thing as taking a third of something. Dividing by 3 is taking a third of it. Or we know that when we divide, we could flip the second guy and multiply. So if we flipped this, right now it's 3/1. If we flipped it and multiplied, we could make this times 1/3. So another way to write this is, instead of 6x plus 15 divided by 3, it could be 6x plus 15 times 1/3. And if I write that times 1/3 in the front, it looks a lot more like a distributive property problem. So essentially, this divided by 3 is going to be a third, and it's going to be distributed across all of these as well. So a third of 6x, it's just asking a third of 6 would be 6 divided by 3, which is what this was here anyways, right? Divided by 3. So we're really taking this division and distributing it through. So 6 divided by 3 is 2x. 15 divided by 3, a third of 15 is 5. And there's our simplest form. So when you go back and look at this, when the whole thing was being divided by 3, did we also divide everything in there by 3 to get our answer? Yeah, it's the same idea for that distributive property. So this one, we could look at this and say, okay, we're distributing this dividing by 2. I could divide everything in here by 2. And I'm going to get a simplified expression, but I'd have to divide everything by 2. So I also could change this into, instead of divided by 2, times the reciprocal of 2, flip the second guy and multiply. Dividing by 2 is the same thing as taking a half of something. We've talked about this a lot. So a half of this whole thing, 1/2 times all of that. And if I do my distributive, a half of 2, a half times 2 is 2 divided by 2. Half of 2 is just 1b, or just b. And a half of 12, half times 12 is 6. 12 divided by 2. 1b, or just b plus 6. All right, let's do one more where there's a couple of distributive properties going on. This one, do you see that there's a 1/2, and we're going to multiply it by everything in these parentheses right here. So we're going to take care of that. But when the parentheses end, that distributive property ends. So then we have a whole nother thing going on. And this minus right here, we would need to get rid of. We'd need to change it into adding the opposite. And we've had a situation like this before, where there was a negative in front of parentheses and there was no number there. If there's just a negative in front of parentheses, it means just a -1. So this negative, or -1, also needs to be distributed or multiplied through those parentheses. So this is just a double distributive property problem. We're going to do 2 different distributive properties, and then we'll be able to simplify. So let's see, what do we have? 1/2 times 6x, a half of 6x. So what's a half of 6? 3, and we still have times x. A half of 14, 7. And then we're done with that distributive property. I'm bringing down my plus here, and I'm going to do this distributive property. -1 times 2x. Negative times a positive is a negative, and -1 times 2 is 2, and there's still an x. -1 times 3 plus -3. So there we've taken care of the parentheses. They're gone now using our distributive property. So now we're ready to combine like terms. We didn't actually have to do that for any of these other examples because there weren't any like terms to combine. When you look at it, it was just a variable and a constant in each of them. But in this one, it reminds us that we want to look for any combining like terms that we might have. So I see some x's, 3x plus -2x. We can add those together and it would become 1x or just x. And we've got some constants, 7 plus -3. Let's be careful with our negatives here. +7 plus -3 takes us down to a +4. So this whole thing just becomes 1x plus 4 or x plus 4. Way simpler looking than this one right here. Okay, so you want to make sure you can use that strategy when we're doing practice, when you've got a fraction in front, that you know what to do and it doesn't throw you off.